Okay, in this demo we're going to talk about how to use the OLI ESP program to create a stoichiometric reactor. The first thing we're going to do is launch ESP, which you see before you, and then we're going to select ESP process. We can select from many different processes. We're going to create a new one. We're just going to call it R2. Then we need to create a chemistry model, and we're going to do that here. Chemistry model names can be the same or different than the process name. We're going to create a new chemistry model. We're going to call it formic. And in our example here, we're going to take formic acid and react it with peroxide. We're going to use the mixed solvent electrolyte database. I'm going to select it, then press the space bar to use it, and then press enter. I can specify up to 10 databases. I have none I wish to specify here, so I'll just press enter. Now I need to type in my species. Water is always there, so I'm going to type in formic acid. My reactant is peroxide, and its product is going to be carbon dioxide. So I need to have both the reactants and the products specified in my inflow list. Now creating the chemistry model is probably straightforward. All we need to do is press enter a bunch of times. I'll press enter here. That gives me a blank line. I'll press enter again. That allows us to select phases. I'm just going to select the default phases, pressing enter. And I'm now going to let the program continue. That's the default action. We use it most of the time. The program runs very, very fast, and you can see most of the window is off the screen. Press enter to continue. I can now modify the chemistry model if I need to. I don't need to, so I'm just going to press enter. Once again, I'm going to select continue and let the program run. The program is actually going to the database and looking for all the chemical species and reactions and thermodynamic parameters it needs to calculate the equilibria. And now it comes back. Once again, we press enter to clear these kind of screens. And I can modify the model again here. I could add some simulator connectivity here, such as the Aspen or Pro2. I'm not going to do any of that. I'm just going to select enter. Exit. I'm now going to select process build, and I'm going to put together a single reactor. I have a choice of reactors, conventional, multi-stage, and environmental, and so forth, and I can just move the cursor around. Reactors are found under environmental blocks. And from here I have a bunch of choices as well, but I'm going to select reactor. That's what we're interested in. And I'm going to select an aqueous reactor. It's a bit of a misnomer now to call that an aqueous reactor in the mixed solvent electrolyte database, but it is more of a default reactor. So I'm going to go ahead and select it as a default reactor. And everything in ESP requires a name, so I'm just going to call this the test reactor. I'm going to call the feed. I'm going to call the effluent. And now I'll go back to select the feed and give it some input conditions. We're going to do this at 25 degrees, 1 atmosphere. I'm going to put in 100 moles of water, 1 mole of formic acid, 1 mole of peroxide. I will then use the program to sum up the total amount using the normalize feature. And I will normalize the component flows. Actually, that's exactly the opposite I wanted to do. So once you make a mistake, you can correct it. Once again, it's 100, 1, and 1. And I will normalize to total flow. There we go. So I have 102 total moles, 1 mole of each component, 100 moles total water. I can then save this by pressing the F3 key. I now need to specify the actual conversion or stoichiometric reaction. That's done through parameters. So I'll go ahead and select parameters, and I'm going to select reactions. There's going to be a new reactant. My reactant here will be formic acid. Now the rule here is that the reactant and the species in the equation must exist in that inflow list I originally created. That was the very first list I typed in with only the 4 components. I'm going to convert 50% of the formic acid, assuming I have enough species in my equation. And here's a start. So it starts formic acid plus peroxide, giving me CO2 plus 2 waters. And there I've created it. We can go back and edit it to take a look at it in detail. But all of these species, the formic acid, the peroxide, the carbon dioxide, and water, they are the species in the inflow list. You notice that there are no ions here, vapors or solids, or any other designation. It can only be in terms of inflow species. Okay, we're now ready to run it. So I'm now pressing the F3 key to return all the way back to the mode screen. I'll now select Process Analysis. There's no other option to do here except Calculate, so I'll press Calculate. The program will run very quickly. When the screen stops scrolling, which it has here, you can go ahead and press the Enter key. Now I can take a look at some of the results. I'll select Process Stream Results. I will look at the feed. That was the inlet. And you can see that I have 1 mole of peroxide. That's what I put in. I don't have quite 1 mole of formic acid here. That's because formic acid has dissociated into some other species here. And you can see that the pH is very low. Now we'll go through the reactor. So we'll take a look at the effluent. Okay, and you can see things are quite a bit different here. If you look over here, CO2 has been created. There was no CO2 initially, and we have about 0.44 moles in the vapor phase, about 0.48 moles total of formic acid. And it's volatile, so it all bubbled out of solution. Now we'll look at the formic acid. It's 0.48. It's actually almost the sum of those two, which is what it should be. So we had 1 mole initially, and we're left with about approximately a half mole as a result. So we've had 50% conversion of the formic acid. And you can see that the peroxide is also, since it was a 1-to-1 ratio, a 50% conversion as well. The block report doesn't have too much. It just tells you what got converted. It tells you that the key reactant was in fact formic acid, and it's being subtracted at this fraction. If you wanted a different fraction, we can just go right back to Process Build, back into the reactor, once again selecting Parameters, Reactions, Formic Acid, and we'll make it different. We'll make this 0.75. We'll leave the equation the same, and we'll simply go back and rerun it. Once again, we'll just press Enter to clear the screen, and once again, we'll look at the feed. The feed is unchanged because we didn't do anything to it, but we'll look at the effluent, and you can see that we've got a lot more carbon dioxide. So very quickly you can change the stoichiometric ratios here that you need to get different results. And this block is useful since we're able to do these conversion reactions without having any real kinetic data. We don't have to know anything about the size of the reactor, the hold-up time, or anything of that nature. So we can do some very, very quick and dirty calculations to see if we're going to have any conversion at all. Thank you for your attention.